Hi, everyone. Good afternoon and welcome to the Good Systems Speaker Series. Thank you so much for joining us today. Good Systems is the interdisciplinary research grand challenge at UT focused on defining, evaluating, and building ethical AI systems for the benefit of society. My name is Stacy Cayley. I am the Network Relationship Manager for Good Systems, and on behalf of Good Systems, I'm pleased to welcome you to this great talk. We have a great lineup for you this afternoon with Dr. Josh Harguess. And I'm happy to introduce you to our host, Dr. Ken Fleischman. Dr. Fleischman is a professor at the UT Austin School of Information. He's the founding chair of Good Systems, the founding editor-in-chief of the ACM Journal on Responsible Computing. And he is a co-lead on our Making Smart Tools Work for Everyone project. So without further ado, I'll turn it over to you, Dr. Fleischman.
Thank you, Stacy. Thank you, everyone, for joining us. So we're really delighted and honored to have a very distinguished speaker today, Dr. Josh Harguess. So Dr. Harguess is the Department Manager of AI Security and Perception in the AI and Autonomy Innovation Center at MITRE Labs. He's been at MITRE Labs since 2020. Before that, he was at Shield AI. He does research in computer vision and machine learning. Dr. Harguess's research has resulted in numerous awards and patents, as well as more than 60 publications. And Dr. Harguess is an alum of UT, receiving his PhD from UT Austin in 2011. So thank you so much, Dr. Harguess, for joining us today. Looking forward to your talk.
Great, thank you so much, Ken. Let's see if this works still. Okay, can you see my screen? Perfect. Okay, thank you very much for joining everyone today. I know it's right after the holidays. I'm still kind of hazy from the holidays as well. So this work is kind of the closest match of some of the work we've been doing to the Good Systems work. So hopefully there's some good overlap here. Hopefully there's some interesting discussion afterwards. But what we're looking at here, we're looking at kind of a lens backwards and seeing what caused sort of previous winters in AI, if there's anything that we can learn from that, and try to kind of set up a framework for how to deal with potential future winters. So coming from, I also spent 7 years in the Navy, one of the Navy research labs here in San Diego. So one of the ways that we communicate things is bottom line up front in that world. So kind of two takeaways here. So a big boom, obviously, in AI has happened over the past decade, couple of decades. That has exposed some vulnerabilities of the technology that could cause the next AI winter. So really what we want to do is summarize implications from those previous winters, kind of build some knowledge about how those winters happened, and then also consider a framework going forward within AI assurance as a potential deterrent to future winters. So one nice framing of this is a book by Isaac Asimov. So it's called The Choice of Catastrophes. So what this book kind of entailed is, how different classes of catastrophes that could happen to the human race, from class 1 events, which are things that we absolutely cannot avoid, things that happen to the universe itself, all the way down to class 5, where there are some things that we could control, something that would wipe out the civilization, like disease. So kind of looking at this framing, are there any things that we can avoid, catastrophe-wise, in AI with knowledge and planning? Can we kind of look at causes from the past and see if there's any way to avoid these sorts of things in the future? If you haven't seen this book or read this book, I do recommend it. So one one way to kind of gauge the activity that's going on in AI is to look at, paper acceptance rates. So CVPR, very large conference within AI, machine learning, and computer vision, that has had an very rapid growth, both in submitted publications and then also in accepted. So we can see this growth year over year. And I think I saw the number already, something in the 9,000 range for submitted this year. So yeah, it's just continuing to increase. However, we definitely see some issues with today's AI. Many examples of this exist. One here that we're kind of showing is a really simple attack that you can do with just some really simple stickers that can cause a Tesla autopilot to swerve into the wrong lane. So security issues for sure, but there's other issues. So we kind of show that AI is greedy right now, takes a ton of resources. It's brittle. So this example kind of shows that. Opaque, so we don't quite know what's going on under the hood. And then also shallow. It doesn't have the generalizability to multiple tasks that we sort of want it to have. So this slide kind of summarizes the next few slides and what I'll be talking about. So based on the past AI winters, what can we kind of see with what's coming in the 2020s and beyond? So boom one, we had symbolic AI as kind of the driving force of that. We had a winter after that. Boom two was kind of framed around expert systems. We had a winter after that. And now we're living in this boom that's really driven by data and machine learning. So 3 possibilities. AI, continues to sort of accelerate like we're experiencing right now, becomes pervasive. A second option where it starts to taper, but certainly pieces of AI definitely remain relevant and stick around in society. And then the third option looks a lot like past winters, where we kind of get some stalling and momentum, and then we have a winter that we very much do not want. So I'll hit on some highlights here. So boom one, we have AI, the actual phrase itself. That credit's given to Marvin Minsky and John McCarthy. They hosted a workshop in 1956 at Dartmouth. That's where that term came about. We also have Alan Turing introducing the Turing test. So very important milestone there. We also have the perceptron being introduced. We have nearest neighbor search. And we also have ARPA. So Advanced Research Projects Agency was created. Lots of money came out of that to folks at MIT, CMU, Stanford, etc. Some interesting quotes here. So H.A. Simon in '65 said machines will be capable within 20 years of doing any work a man can do. Marvin Minsky in 1970 said a machine with the general intelligence of the average human being could be developed within 3 to 8 years. So some pretty bold statements, and that led to the first winter. So winter one, you can kind of largely summarize as bad PR. You can kind of point to some of the statements and some of the promises that were made, and not really kept, mainly because of how bold those statements are and really what AI could do at the time. So a British mathematician, James Lighthill, published a report that said really the opposite, said AI could only achieve experienced amateur status in games and really would never achieve common sense reasoning. Subsequently, not completely due to only that statement, but other factors. The British government reduced support for funding, and then excuse me, the U.S. government followed suit. So some pretty big hits funding wise to AI research. So once funding dries up, it's really difficult to continue on. So problems that were existing back then that are very much dealt with these days, limited computing power, really couldn't handle the sort of vast amounts of data needed. And so lots of infrastructure, lots of kind of background hardware and software work that needed to be achieved. So boom 2, that's really around kind of expert and knowledge-based systems. That really became a large industry, billion-dollar industry by 1985. However, it's really kind of one concept at a time, very hand-driven, so kind of rules-based. So it's difficult to scale. But some really huge investments were returned. You can see some examples here. A big one from the defense side. DARPA created the Strategic Computing Initiative. And then also you see kind of the return of some ideas in neural nets. So we have backpropagation being introduced at this time. Okay, so winter 2. Once again, we have a funding collapse. We have some AI hardware market crashing. We had, like I kind of mentioned before, pretty hard to maintain, pretty expensive to retain, and difficult to scale. And then, of course, you have a funding cut by DARPA that definitely leads to deceleration of interest and research in the area. So some achievements, though, during this winter, reinforcement learning was a big one in 1989, and then also temporal difference learning. Boom 3. So this is really where kind of the current boom kind of takes off. So some milestones here. 1992, we have support vector machines. 95, we have random forests. We have long short-term memory. We have some big milestones as far as AI sort of versus humans. So Big Blue beats Kasparov. We have big data sets that are being set up. So MNIST data set at the end of the 90s. And then probably most people on this line remember the DARPA Grant Challenge. So very, very important for this field. And then we have in 2006, Hinton coining deep learning. So some of the kind of highlights here, we have a switch to very much data-driven work here. So, fewer of the kind of rules-based hand tuning of things and more of a drive towards using data to build models. Also, another important one is that we actually do have more focus on mathematical foundation. And of course, behind the scenes, you have many important areas kind of emerging: data mining, industrial robotics, speech recognition, search engines, etc. So continued explosion into obviously the 2010s and up to today. Really can't name them all. It's getting pretty hard to track, pretty hard to gauge just because of the explosion of applications and sort of achievements. But really some big advances in CPU, GPU, data storage, obviously machine learning has really created a lot of the excitement, the activity, the capabilities that we see today. So you see some milestones there. Netflix Prize pretty early on. Kaggle comes out in 2010, all the way down to AlphaGo and AlphaGo Zero. So some pretty big achievements with AI machine learning methodologies starting to really compete with human level sort of knowledge and achievement in things that we weren't exactly sure that they would ever sort of have a chance to compete. So taking the lens and kind of looking back at that, those winters and also kind of the booms, what are some lessons learned that we can kind of take away? So if we do kind of a word cloud, and take a look at what some of the analysis that was done on those past winters kind of has to say, we find some common terms that people are using today about how do we sustain, how do we make AI more robust, things like that. So we see robustness, we see fairness, we see things like security, ethics, responsible, resilience. So we see a lot of themes that we kind of see from other analysis that's happening today. So there's definitely concern from past analysis on these winters about operationalizing AI and making it widespread. So some examples of some ways forward that some organizations have been working on. There's a National Security Commission on AI. They created a final report that really highlighted how to go forward, where we should be making our investments for robustness, and then also in things like security, where we really should stand up something like an AI red team. And I'll actually talk about that towards the end of the talk. DoD also, Department of Defense, created a responsible AI strategy and also an implementation pathway. The European Commission likewise did a very similar activity, kind of creating a high-level expert group on AI. Large companies have done the same thing. So anybody that's putting a lot of investment behind AI, Google, Microsoft, Facebook, IBM, they have their own frameworks that talk about responsible, ethical, trustworthy AI. And so it really is starting to kind of culminate around this idea that we need unified strategies and also frameworks for kind of dealing with some of these issues that we've seen in the past. So a couple of examples. I'll pause this one for a second to focus on the left. So consequential uses of AI. So obviously there's lots of different uses of AI. There's shopping, there's search engines, there's all sorts of ways that AI is being utilized. But really what we're focused on at MITRE and in our department and the Innovation Center is consequential uses of AI. So obviously we have a situation on the left there where the Tesla just went underneath the semi-truck. This is obviously just a little GIF to kind of recreate that scene, which was a Delray Beach accident involving a Tesla car and also the semi-truck that you see there. So very consequential use. And then on the right, we have a drone that you could pretty easily scale up to a swarm of drones. And we have a kind of a situation here where the attack really is to put some really simple patterns out into the scene and then disrupt visual navigation. So when you do that, now you can basically take over the drone. You can make it land. You could also, make it crash if you wanted to. And then if you had a swarm of these, you could imagine the kind of damage you could do in that case. Okay, so what we're kind of introducing, and a lot of people are doing the same, is sort of a framework around assured AI. And so, you're probably going to see a lot of these rolled out over the next, 2 to 3, maybe 5 years. But really, it doesn't matter which one we sort of embrace, as long as they have kind of elements of these things. So security, we're spending a lot of time in that space. Fairness, trust, resilience. And if we break those down, kind of what we're talking about here, for security, it's exactly what we kind of saw from the NSCAI report. Really try to focus more advancements on security and robustness. We have something called MITRE Atlas, which is the adversarial threat landscape for AI systems. I'll talk a bit about that later. And then the other 3 areas, we have fairness and bias, where that really involves the data. The data can be fair or biased, unfair or biased. Algorithms created from that data could also have elements of those. And then an important element of all of these is how to measure. So specifically, in this case, measuring bias and fairness, but metrics for all of these is a very important aspect. Upper right, we have trustworthy. So that gets to that opaqueness. So can we explain what we're doing, what the model did? Can we predict what the model is going to do? NSF definitely sees a future here with the creation of the Institute on Trustworthy AI. And then on the bottom right, we have robust and resilient. And so one way to kind of look at this is, test and evaluation. So that's something that has been done in engineering and manufacturing industries forever. But how do we tweak those to sort of create a T&E 2.0 that works on AI? We also need things like baseline capabilities. So, where are we right now? If we were to kind of test systems and sort of make a benchmark assessment, what would be some of the key performance indicators, and then how would we use those to inform investment decisions? Okay, so since I don't really have time to dive into all 4 areas, let's do a deep dive into just one of them. So let's look at security. So establishing AI red teams is something that the NSCAI report talked about. So we'll spend a little bit of time on that here. Okay, so we've kind of seen the need for this in some of the previous slides, but this is a nice view of sort of where vulnerabilities could lie in the entire AI supply chain. So we have, sort of pick anywhere in here that you want. You have your compute. You need to secure that. You may have memory storage and things like that where you have sensitive information about model weights or something like that. We also have, target lists, labels essentially that you could infer attacks on particular sensors. Training data is a big one. We've seen attacks that can create a backdoor into the model and actually reproduce training data, as well as poisoning the training data so that you can kind of use the model at will. And then the model itself. So you can create proxies to the model, and then you can sort of predict what these models are going to do, and then you can mount attacks on those models. So many different aspects of this kind of entire AI supply chain that are vulnerable to attacks. So some really simple ones that you may have seen in literature. We have the really popular one in the top right. This is from Ian Goodfellow and his group. This was back in 2017 or 2015, sorry. So in this case, we just have a very small amount of noise that's added to some image. Here we have a panda, and the model has pretty high confidence before you add this noise that is indeed a panda, and then after you add this noise, it's very imperceptible to humans. I can't pick out the noise in that last image, but the model is very confident that it's now a gibbon. So very tricky and very dangerous application of a security issue there. So number 2, we have a similar situation, except we're not adding something to the entire image. In this case, we're actually just inserting a patch into the scene, and that changes the classification from banana to toaster. Number 3 is an interesting one because it's not some strange looking object in a scene. You're just placing pretty benign patches of like black and white rectangles, and you're able to change a stop sign into something that's not visible, or even a speed limit sign. And then the 4th one there is some work that actually we've done at MITRE, where we do these attacks in the physical world. So we print these out and test them out, see how robust they are. and also kind of test defenses to them in the real world. So the characteristics of an AI red team, since I mentioned that before, you really have kind of four elements. So you want to be independent and empowered. You want to be able to have a short chain of command to senior leadership in your organization. You also want to be connected to sponsors, funding agencies, et cetera, but separate. So you want to be coupled to them, but separate from them. You want to be informed, so you want to have subject matter experts, and you want to build a team around these experts. That team might consist of things like system engineers, it might consist of cybersecurity professionals. So it kind of depends on what you're trying to build out as far as an AI red team. And then obviously you want it to be evidence-based. You don't want to just make sort of qualitative assessments and recommendations. You want to see kind of hard data behind the recommendations that you're going to make. And so the role of the AI red team, this slide kind of shows from all the way from kind of a real world mission, where in this case, I'm very much focused on computer vision. So you'll see, mostly computer vision examples in my slides. But you could replace that with lots of other uses of AI. So here we have this real world mission. We want to understand, sort of counter AI operational problems and gaps. We want to leverage available tools, both from industry, academia, and then also, anything that's created in, Department of Defense labs, UARCs, FFRDCs, which is where we come from. And then you kind of leverage those in your research. And so what you're trying to kind of do is develop operational threat models, identify threats and reduce the risk, and then also identify relevant sort of technical evidence, back to kind of that, getting some real data-driven sort of results. So the products that a red team might create, you might inform investments, you might sort of do some technology specific protection and planning. You might coordinate some sort of collection of, for a specific kind of a mission. You might also do exactly that for sort of the counter of the intelligence that you're trying to gather. And then at the very end, what you're really trying to do is inform the development of additional tools and research, kind of back to the tools that are available for AI red teaming. And one of the elements of AI red teaming is this idea of kind of mission analysis and threat modeling. So here we have an example of one. I'll talk a bit about the playbook that we're building at MITRE for AI red teaming, but this is definitely an element of that. So here we have kind of goal-driven threat model. So the goal in this case is to make the object detector ignore people and vehicles. There are some, lots of different sort of branches to go down here. One is maybe you get physical access to the camera. And in that case, you could do a lot of interesting things that, you may not need to do anything fancy. If you can just remove the power source, if you can just put a sticker over the camera. So we want to understand the entire kind of space of vulnerabilities, not just to the AI algorithm itself, but to the system. And so that's one kind of different aspect about what we're trying to do. And then if you follow the orange path, this is really the majority of the work that we've been doing the past couple of years, which is, what can we do? What is a realistic thing that we could do to put into the scene that might cause some sort of an object detector to fail without having physical access to the model, without having physical access to the camera, the hardware, anything like that. What are some of the things that we could do? And you've seen some examples of this with this adversarial patch, but there are many others. So I mentioned Atlas before. So this is if you've done any work in cybersecurity, there's something called attack that is also run by the MITRE website. So that atlas here is really kind of a mimic of what attack is for cybersecurity, but within the sort of threat landscape for AI systems. And so you'll see some similar things like, techniques under reconnaissance, for example. If you have initial access to the system, if you have defenses that you want to try to use against these attacks. So we'll have some different techniques under each of these. And then one of the most important parts of this is the case studies. And so that tab there actually shows real world examples that people have submitted to the website. So they'll actually go through, show which of these techniques were used, what the result of that was, and any sort of countermeasures that they plan to use in the future. So the AI red team process looks a lot like this. So really what you're trying to do is break this kind of system engineering problem up into many layers. So first you want to analyze your target system, kind of like we were talking about before with the threat model. Understand where the vulnerabilities are. Then you want to assess and build a target model. Then you can build an attack based on that. Launch the attack. Actually launch it into the world. You may try to do like a data collect, a live collect, or something like that. And then finally, you want to do this impact analysis. And the impact analysis is interesting because it's not just how did the algorithm fail. It's more about the system. So what was the impact of the failure on the end user, for example, and their decision-making process. But there's really sort of two areas that are kind of often left out of this process. One is the kind of pre-attack phase, we're calling it. This is where you're trying to build your team. So you need to do recruiting for the right talent that's going to create that team. And then obviously you need tools. For the very end, when you're done with your impact analysis, the post-attack phase is what we'll talk about on the next slide, which is feeding this to blue teams and yellow teams. So yellow team in this build, attack, defend model is really the team that's responsible for building it. The system that has the AI algorithms in it, the AI algorithms themselves, but they're not usually too concerned about what a red team is going to do. They're not too concerned about defenses that they might stand up. They're mostly concerned with just making AI systems work. So usually what they'll do is very basic T&E. They'll do test and evaluation. They'll make sure that the algorithm is robust to certain elements, but they won't think too much about red and blue team. So what this pyramid really gives you is once you kind of go down from yellow team to red team, where you're going to actually make this attack happen, now you have this sort of orange area, conveniently colored here. So you feed back red team sort of activities to the yellow team. You may also feed the red team activities to the blue team, and that sort of becomes a purple team. Blue team is really about defending. They might try to defend without any red team knowledge. That's kind of a pure blue team. And then really what you're trying to do is complete this pyramid by having the entire flow happen. So once you inform the blue team, then they inform the yellow team through sort of green, and that's sort of how you complete this entire cycle. And that's really the way we're trying to frame going forward for security and resilience as far as that pillar within AI assurance. And I mentioned this earlier, but one thing that we're working on is something called an AI red team playbook, and we're hoping to release this sometime early next year. But the idea here is, what is sort of the playbook? So from why you want to stand up an AI red team, if you are doing any sort of utilization of AI in your systems, what an AI red team looks like. What team members sort of skill sets need to have. And then it kind of takes you through all these steps that we've talked about here, how you would actually assess vulnerabilities of a system, how you might build an attack, how you might evaluate that attack, and then also talk a bit about that impact on the mission success. So what was the impact for the end user if somebody's making a decision, human in the loop, human on the loop sort of activity. So we're hoping to release this, like I said, sort of early next year, maybe March, April-ish. But if anybody's interested in following up on this, please let me know. And with that, I think I've almost spent my allotted time. Obviously, there's a lot of other topics to cover here for the other 3 pillars, but this gives you kind of a lens into some of the way we're thinking about the problem. And we're not unique. There's a lot of organizations thinking very similarly along these lines. So with that, I'll open it up to questions.
Awesome. Thank you so much, Dr. Harguess. Awesome work. Who'd like to ask the first question? Yeah, Tina.
Yeah, I'm interested in this AI red team playbook that you said. Is that
Great.
like a high-level playbook for all teams, or do you separate it for the different AI systems, and how detailed does it get? And how, is that like a work in progress that gets constantly changed also?
Yes. So the vision for it is definitely a sort of work in progress at all times. So I think it's something that we're going to add to yearly. We're going to make the first sort of crack at it. So we'll release a version, like I said, sometime early next year. But really, the vision for it is to have contributors from everyone. So like academia, UARGs and government and other folks like that, that have specific things that they kind of want to bring to the table. As far as how we see it, kind of like an outline playing out, is yes, we will detail in sort of a generic way what an AI red team should look like, not caring too much about what system it is or what algorithm it is that we're trying to red team, and then having specific kind of ConOps, so concept or operations that we go through. So obviously a computer vision one from my background, but then things like audio classification, or RF sorts of applications. So we do plan to have examples of things that are not just computer vision, but sort of try to show a little bit of the breadth of the way to do this.
Thank you.
Thanks.
Awesome. Next to Nitin.
Thanks, Ken. Thank you for the talk, Dr. Harguess. So my question is about the metaphor of the winter coming. So I just wish to understand the true locus of concern regarding the use of that phrase. Is it that the winter is going to be limited only to the US national context, and that the winter might not be global in some sense, and therefore there might be some strategic disadvantage? And part 2 of my question, which I'm also curious about, is what do you think of progress in quantum computing? Is that something that is going to give the next step up to the next generation of AI capabilities? That do you have a finger on that?
Yeah, I'll answer your question, your second question first. I don't have my finger on that. I think we were all surprised at the impact of GPUs in machine learning and the acceleration of AI through the massive amount of infrastructure built around GPUs. So I think quantum computing has the ability to surprise us even more. I think in this space, there's already some working examples of doing machine learning on very basic things with quantum computing. So yeah, unknown, but I would imagine it's going to have a big impact. As far as your first question, yeah, so the reason we're kind of framing it around winter is I think we're in a unique place where we're not going to see a true winter. We're not going to see AI disappear from every facet of human life. It's just not going to happen. So I think where we're focused on a winter is really operationalizing AI for consequential uses. So I think the driverless car example is a great one. Are we really ever going to get there? Are we ever going to trust these systems enough? We keep pushing that timeline into the future, and probably for good reason. And so I think that's kind of where we're focused on when we talk about winters.
Thank you. Thank you.
Awesome. Sharon?
Yeah, thank you. And thank you very much for the talk. Really great to get to know what you're up to. I was caught on one of your earlier slides in which you discussed the 4 elements of AI assurance that your group is focused on, one being fairness and bias. And you said that there are difficulties with measurement. I was wondering if you could expand a little bit on that, and what some of your thoughts are on measurement and indicators more generally.
Yeah, so really good question. So we have done some work in, I think the easier question is bias. So we've done some work in understanding where model bias comes from, where data bias kind of comes from, model drift, when some of the elements that an algorithm experiences when it's out in the real world is quite different from the training data that you gave it. And we're still very much in the static sort of training of these systems. They're not very plastic yet, so they don't learn on their own when they're out in the field. So that's a little bit easier to measure, sort of what this bias is in models, and maybe how to correct it. Fairness is where we get into really tricky territory. So you can measure things like, is there a particular part of the population that's underrepresented in the data set? So things like that. But it's difficult to measure maybe impact. So if you use an AI system to automate credit ratings, you really need good metrics to understand the impact when that system fails and when it goes wrong and when it makes the incorrect sort of recommendations. And there's a lot of work going into building metrics for systems like that. Recommender systems is another one. And so there's just a lot of work to be done there, I think is really what I was focused on.
So just a clarification then, the way you're framing bias is almost more akin to veracity?
Yeah, I think that's probably right.
Yeah.
The bias that we're sort of dealing with, I mean, from a computer vision standpoint, is more about representation of data within training sets, and so that's really where we see the biggest sort of gap. One way that we've been kind of handling that is actually through synthetic data, and I know that's a hot topic right now with a lot of folks, but that does seem to be a good solution, or at least a partial solution to that problem.
Awesome. Craig?
Yeah, thanks, Ken. Thanks very much for the talk. That was quite interesting. Thomas Dietrich at the University of Oregon has talked about high reliability organizations, like the nuclear navy that's never had a nuclear accident and other parallels to that, to try to apply those philosophies to these problems of AI that you're talking about. And I just wondered whether you had, do you know of Dietrich's work, and whether you had any insight into using that phrase? I think it overlaps, but it's not quite the same thing as what you were just talking about.
Yeah, so it's interesting. We do have collaborators at the DOE, for example, and we do know that they are thinking about things in those terms, very much because they are planning to use AI in a lot of those systems. So I think the framing is correct. We haven't necessarily tried it on our side. That is something, this is in its early stages of defining all these things and kind of working our way forward. But yeah, I think that's really helpful. I think understanding sort of zero risk, zero tolerant kind of systems and applying what they know to this problem makes a lot of sense. However, there are some things that are different. So I used the driverless car example before. What sort of trust knob do we need to turn before we actually do kind of believe in these systems? Humans are notoriously bad at driving. We have so many accidents. It's one of the leading causes of death in the U.S. So where are we kind of okay with AI starting to take over some of that risk versus humans that we kind of already know their risk. And I think that's, you know, not quite the nuclear problem. It's a little bit different than that. So I think it's important to keep two hats when you're thinking about that problem.
Yeah, the driving problem is a subtle one for sure.
Yep.
Thank you very much. Appreciate it.
Thank you.
Okay, Steve.
Yeah, and I apologize. I can't seem to get my video to work, so you'll just have to deal with hearing my voice. I really liked your narrative of the AI winters and the AI, I guess, resurgences. And I noticed a couple of things about that narrative. One is that we seem to have winters at the moment when we have a very good grasp of the given paradigm for AI. When we had a good idea of what the limits of first order logic and game optimization were, is also when we kind of saw that first AI winter. And then we see these resurgences when the new paradigms emerge. So I understand that you're going to be updating your red team playbook and building things up on a yearly basis, but I guess my question is, how practically do we account for the paradigms we don't know yet? Because one of the other things that's clear from your slides is that the range of things we think of as being AI is growing just as rapidly as the various different approaches are. So given that AI describes more things, we're talking about AI playbooks, and we know that these paradigms are shifting at a fairly rapid pace, at the very least once a decade. How do you kind of future-proof these approaches or ensure that your playbook is going to be resilient in the face of change?
Yeah, it's a really good question. So I don't think the yearly update to the playbook is going to keep up. Like I think you're exactly right about that. The thing that is going to keep up at the same pace is really Atlas. And so Atlas is community driven. It is real time. I mean, as soon as somebody has a vulnerability with the system and they're willing to share it, then they'll post that to the Atlas website, and we'll build. Maybe there's a new technique that wasn't established when Atlas was updated a couple months ago or whatever. So that is kind of the more real time analysis of vulnerabilities that we're kind of tracking. The Red Team Handbook, you're right, it's not fast enough. The updates are not fast enough in order for us to keep up. It's more like a journal, I guess, kind of looking backwards at what happened over the past year and things that we should add to it. To your point, though, I think it's more fluid now. I think that's one thing that's interesting about now versus the past winters, is that we're maybe not going to see some sort of one thing that's going to take down AI funding. It's going to come from multiple sources. It's going to maybe be focused on a particular industry. I think the quantum computing example is a really, really good one. That could be just a crazy impact accelerator that we just don't know how to measure at this point. And then there could be brand new things that we just don't know about. So I think as a community, trying to capture these things in conferences, things like Atlas, is really all we can really do kind of going forward. And then there are lots of bodies that are collaborating between EU, the US government, Australia. So we have a lot of collaborations happening to try to keep visibility on some of these activities. But yeah, it's really impossible to predict.
All right. Yeah, thank you. It sounds like having an infrastructure to respond with is a real important part there with Atlas and everything else. Thank you for your response.
Yeah, thank you.
And on that public policy note, Sherry.
Yes, thank you. And I think we just had a partial answer to my question, but we've talked about the winter, and you've talked about threats and playbooks and the known unknowns, the unknown unknowns. My question is from, yes, a public policy standpoint, what, if you had to pick one, what would be the greatest challenge you see today?
Wow. Okay, so From my standpoint, from the users that we work with, it is trust. So getting our users to trust the systems, to not turn it off as soon as there's one mistake, and never use it again. That is really our biggest challenge. And that can be unique just based on the user base that we're working with, but that's really our biggest challenge.
Thank you.
Chelsea.
Oh, thank you. Yeah, thanks so much for being with us today. I really appreciate the framing of the winter and the different causes. It feels like cautionary tales and things that perhaps we can avoid in the future if we think
Hopefully.
about it, right? And what could come next. I hear a lot, of course, you're talking about global inspiration in terms of partners, national partners, of course, it makes a lot of sense, DoD and those kind of federal agencies. I wonder what your thoughts are around local partners, specifically local governmental partners, cities, maybe even county, regional authorities, if that's kind of coming into your purview, and if you're having any considerations about maybe how they play into the playbook, or maybe it's more around informing tools and the research that you were speaking about.
Yeah, great question. So we actually have some collaboration going on with Ken in the city of Austin, and we hope to continue working on that in the next few years. But I think that's a really important problem. I think we talked about it a little bit early on, but recommended systems for that impact actual human lives. That's not really going to happen at the DoD or whatever government agency, federal government level. That's happening at the local level. So those are very important partners. So I live in San Diego, but originally from Austin. So one thing that's very interesting to me is how do we scale some of the things that are being learned in particular cities to other cities that have a very different demographic, potentially, very different systems, very different infrastructure, but we still want to address the same challenges. So I think that is definitely TBD research that we need to do.
Thank you for that.
Thank you.
I'll take the moderator's prerogative and ask the final question then. So in putting together and soon releasing the Red Team Handbook, I wonder, it makes me think about the local news segments where you'll get a former burglar who was, showing sort of tricks of the trade in terms of helping homeowners to take preventive action along those lines. And we see this in terms of hacking as well. This element of how much of the technique do you release that's going to help the builders and the defenders versus how much that's going to help the folks who are trying to do the adversarial side of things. So how do you balance that in putting out that handbook, Josh?
It's a really difficult question to answer. So the only answer I can really give is it depends. So we have, for example, inside of MITRE, we're setting up a council just for some of the projects that we work on, so that we can come to some agreement, just based on the few kind of sponsors that we interact with, on which things we want to share, which things we don't want to share, get feedback from sponsors. Sometimes they very much direct us not to share particular things, which makes absolute sense. So it is a balance. We know that we wouldn't be here if it wasn't for the open publishing model that we have, in AI, machine learning, and computer vision. So that aspect of it is very important. But we also do have real vulnerabilities that if they were exposed, so I talk about the Atlas website, there are things that aren't on there on purpose. And we have to balance, things that are very sensitive that shouldn't be publicly known. Usually what that means is there's a system that is deployed that does have a vulnerability, and we're aware of it, but we don't want to give any information out for a real-time system that's actually deployed. And so it may be something like retroactively, once it's addressed, then we release what the vulnerability was, what the action was to sort of solve that vulnerability, and go forward from there. But yeah,
Awesome.
tough question.
Yeah, that makes total sense. I think that ability to give those retrospective examples that are no longer kind of live grenades, but still can have that same instructive value is really makes total sense. Awesome. Well, thank you so much, Dr. Harguess. Really enjoyed your talk. Really appreciate everyone joining and having a really robust discussion. Thanks so much, everyone.